Okay, so now let's see why we need multi-perceptron. So before this, we were looking just for single perceptron. Okay, so this is the one which we were looking earlier, but now we like there is a question why we need to go with multi-perceptron if single perceptron was able to do was working fine with all the logic gates. Okay, so first let's see the table. So before this, so for n inputs, the number of Boolean function that we can define would be 2 to the power n. Okay, and for 2 inputs, the total number of Boolean function that we can generate it would be 2, so that's 16 Boolean function that we can define with just 2 inputs. So if we look at this table, the Boolean function is ranging it's ranging from all the possible Boolean functions for 16 different possibilities are shown in this table, and within this table we can define even like there is AND gate and there is like OR gate, and there are I'm showing these 2 functions because it has some significance in AI, in artificial intelligence, okay, in real. Okay, so this is XOR and this is not XOR, so which is XNOR, and these 2 functions had some very important significant history on artificial intelligence. Like there was something called AI winter when artificial intelligence was booming, was like totally it was doomed down to earth. Okay, and the reason is like these 2 functions are not linearly separable, so that was the main reason that single perceptron is not able to work for these 2 gates. Whereas for other, if we look at other Boolean functions, all are linearly separable. So that's why even single perceptron is able to work fine with them. Okay, so these are the 2 functions which are non-linear Boolean functions. Okay, so if we see in a graphical way, okay, this is for XOR, and these are like 2 variables, x1 and x2. And if we look at for not XOR, okay, this is x1 and x2. Okay, so this, okay, I'll just go with this. So this is 0 0, this will be 1 0 0 1 to 1 1. Okay, so I'm going to do same in this graph as well. 0 0 1 0 0 1 1 1. Okay, so if we look at XOR, so in XOR, a neuron will fire only when both the inputs are same. Okay, so these are the two conditions when the neuron fire for XOR. Okay, so we cannot come up with some single linear decision boundary which can just separate this region where the neuron fires. So this is the reason where neuron fires, and these are the reason where neuron doesn't fire. So we cannot come up with just single decision boundary. We can separate these 2 regions. Okay, so this is one reason and this is another reason. Okay, so therefore like we have to come up with some non-linear decision boundary that can do this job well. Okay, so it should be something like this. Okay, it should be something like this. So this is kind of non-linear decision boundary, and this is the region where our neuron will fire, and these are the neuron with, this is the region where neuron doesn't fire. Okay, so if we look at so similarly, if we look at X not XOR, the neuron will fire only when the inputs are like different. Okay, so that is like here, this, and this is the condition where neuron fires. Okay, so same thing is here. Okay, so we have to come up with some kind of non-linear decision boundary that separate the region where neuron will fire and neuron will not fire. Okay, so yeah, so this is the reason that single neuron is not capable of finding the nonlinear decision boundary. So it is more restricted to linearly separable what do you say, linear separable inputs, but it's not it cannot work for the non-linearly separable inputs. So this is the reason why we have to why we need the multi-perceptron. Okay, so in the next lecture I'll be like drawing the neural multi-perceptron, which is the base for the neural network. Okay, so which will okay, so okay, so if this is the input, I'm just trying to give some idea how this multi-perceptron will look like. So now, instead of single neuron, now we have multiple neurons. So yeah, that's all. So now if this goes to every neuron, and this goes to every neuron, and this is the output layer, okay, which will be like y is again, which will just define if the neuron will fire or not fire based on the different values for these inputs. Okay, yeah, so this is nothing other than neural network, and this was and like basically it's multi-perceptron. Okay, because it has like multiple perceptron, and which is later known as neuron. Okay, because just trying to mimic our human brain. Okay, this is multi-perceptron. Okay, so now let's discuss about multi-perceptron. So before that, I'd like to make some correction in the earlier lectures. So one of the correction is this truth table, it's not for XOR, it's for XNOR. Okay, so not XOR or XNOR, and this is for XOR. Okay, so this is the correction which I have to. Okay, and this is for XNOR, and this is for XOR. Okay, and one more thing, I'd like to make some just as a remarks. Like I just want to make something clear of some of the concept, like one of the concept that I have, or let's say assumption that I have mentioned earlier. Okay, so if this is a neuron, and if this, okay, this is an input x1, x2, and this is y, which is a Boolean variable for the perceptron. And okay, so this is the one which I want to highlight. Okay, so this one is x naught, and there is w naught. Okay, and these are w1, w2. Okay, so earlier I think I have mentioned the w naught as minus theta and x naught as 1. So which is okay, so this one is bias for this neuron. Okay, linear neuron. Okay, so this negative sign can be either in one of, either it can be like we can make x naught as minus 1, and if we do that, then w naught would be just positive theta, or vice versa. Okay. So therefore, if x naught is -1, then W naught would be positive theta, or if x naught is +1, then W naught would be negative theta. So we can assume either of this possibility. But what I would like to prefer is this one, because just making x naught -1, I'm giving flexibility for W naught to be either positive or negative. So during the learning process, our optimization algorithm will tune W naught, W1, W2, this all the weights. So we don't want to build any kind of restriction or set any constraints while learning for the weights, for the bounding of these weights. So if so they can choose either any positive or negative in order to minimize the loss.